Hey guys, welcome to Master and Learn It. In this video, we're going to be learning about isotopes and relative atomic mass. What are isotopes? Isotopes are atoms of the same element with the same atomic number, that means the number of protons, but different nucleon number. Remember from our previous video, we realized that all atoms of the same element have the same atomic number. That means this is a carbon atom because it has the atomic number 6. This is also a carbon atom because it has the atomic number 6, as well as carbon 14 also has atomic number 6. That means carbon 12, carbon 13 and carbon 14 all have 6 protons, which is the atomic number. So we call them carbon atoms. But when we look at them, we see that this carbon 12 atom has 12 nucleon number. Carbon 13 has 13 nucleon number. And carbon 14 has 14 nucleon number. That means if we take carbon 12 and carbon 13 and carbon 14 and we weigh them, their mass is not the same. But remember, they are the same atoms. Why? Because they have the same number of protons, which is the atomic number. They all have 6 atomic number. So that means they are the same elements or the same atoms called carbon, but they have different masses. So how do we represent them on the periodic table? Am I going to represent them using the weight of 12? Or I'm going to represent using the nucleon number of 13 or of 14. We need to find an average number. So on the periodic table, we're never going to see carbon 13, carbon 12, and carbon 14. We just find the relative mass of all these 3 isotopes. So by definition, an isotopes is an atom that has the same atomic number, which is the proton number, but their weight is not the same because of their mass number or the nucleon number. For example, let's take a look at this example. In real air, in this air, chlorine is found in 2 isotopes. That means we have 2 types of chlorine in the air. That means the first type of chlorine has a nucleon number of 35. So that means this chlorine has 35. That's the nucleon number. And the chlorine 37, that means it has 37 nucleon number. So they don't weigh the same. But how do we represent them on the periodic table? If you look at the periodic table, you will see it's written like in this manner. It has 17 there, that represents all this chlorine have 17 protons. So they have the same atomic number. So they are the same atoms. But they have different values. So this is an example that we're going to do together. It says chlorine is found in nature as 2 isotopes, chlorine 35 and chlorine 37, in the ratio 3:1, or 75% is to 25%. So in this nature, then they say calculate the relative atomic mass of the chlorine element. In other words, they are simply saying we found 2 chlorine elements. How are we going to represent them on the periodic table? What mass are we going to use? Are we going to use the mass of chlorine 35 or 37? We need to find the relative atomic mass. So this is how we're going to do show you the calculation of relative atomic mass. So we're going to use method 1, which is the first method, and we're going to use method 2. So the calculation is really simple. Suppose you are just given these ratios. You are not given these percentages. So what are we going to do? We're going to simply say chlorine 35. How many abundant? How much more do we see it in nature? It's in the ratio of 3. So that means we have chlorine 35. How many are you in your nature? That's 3. Plus we have chlorine 37. How much are you in your nature? That's we have chlorine 37, and in nature is in the ratio of 1. All over the total number of your ratio, which is 1 plus 4. 1 plus 3, which is 4. So when we multiply these and divide them, let us just do that on the calculator there. We have 35 times 3 plus 37 times 1 divided by the total number of their ratio being 4. So we get 71 over 2. When you write it as a decimal, then there we go. We have 35.5. That's why on the periodic table we see the value 35.5. Method 2 is also relatively easy, so I'm going to write it underneath. That's method 2. So using the method 2, we're just going to say, suppose you're given a question as a percentage. So how are you going to express that? That's pretty simple. We're simply going to say 75% means over 100, isn't it? So we can just punch the 75% of what? Of chlorine 35. So we multiply by chlorine 35, plus we have 25% of chlorine 37. So when we punch this, we're still gonna do the very same calculation. So we have 35, so we have 75% rather, 75% times 35 plus 25% times chlorine 37. Then there we go, that's our calculation. Then we have 71 over 2, that simplifies to 35.5. So that was the video about the calculation of isotope, the relative atomic mass that we see on the periodic table. So we realize that in nature we have same atoms, but that have different masses because of their nucleons. They might have more nucleons than the other. That means if we are to look at this one, carbon 12, that means it is 6 protons. So 12, remember our equation, we say 12. Our equation, it's A minus Z equals to number of neutrons. So that means here we have 12 nucleon number minus atomic number 6. Then we get 6 nucleon number, or number of neutrons rather. In carbon 13 we have 13 nucleon number minus our atomic number being 6. There we go, 13 minus 6, we have 7. So we have 7, the number of neutrons. In carbon 14 we're still gonna say our nucleon number is 14 minus our atomic number being 6. There we get 8. So we have 8 number of neutrons. That means carbon 14 weighs more. So for us to find an average of all these carbon, we need to use these same calculations. Thank you for watching the video, and watch the following videos.